This problem is a simple dilution problem. That's why we don't have anything about anything reacting, so we wouldn't need a balanced equation. If this was a problem where we were looking at, let's say, the number of moles that we would need of hydrochloric acid to react with a certain amount of sodium hydroxide, we would need a balanced reaction to know the molar ratio to be able to do this problem. In this case, though, it's a simple relationship between the moles at the beginning is going to equal the moles at the end. And the way that we know that is that it's just dilution. So we've got a volume, which is the centimeters cubed, and a concentration of 2 moles per decimeter cubed. And we also have a final volume, which is going to be 500 centimeters cubed. And what we're looking for is the new concentration. So concentration of the initial times the volume of the initial is going to equal the concentration at the end times the volume at the end. Again, I have my initial volume and concentration, and I have my final volume, and I'm looking for my concentration too. So I can rearrange this equation, and I can look at my units, but they're not going to have a large impact on me because they're all going to cancel out nicely. So we have 2.00 mole per decimeter cubed multiplied by 5.0 centimeters cubed equal to my C2, the thing I'm looking for, by my new volume of 500 centimeters cubed. That's the final volume that it's going to get to. To get the centimeters cubed on its own, or the C2 on its own, we're going to divide each side by 500 centimeters cubed, so that cancels out. Divided by 500 centimeters cubed. Here my unit of centimeters cubed cancels out, which is why I did not need to convert it to the decimeters cubed that I have in my concentration. I'll end up with just a unit of moles per decimeter cubed, which makes sense because concentration should be measured in moles per decimeters cubed, or written the way that it's written up here, moles times decimeters to the -3. That -3 again puts it on the denominator of our fraction. So we have roughly 5 times 2, that's just 10, divided by 500. Looking at our answers over here, C would be the correct answer.